In order to perform the Walkley and Black method for organic carbon determination, we need the following chemicals. Number one, Mohr salt, or which is also commonly known as ammonium ferrous sulfate hexahydrate. In order to prepare this chemical, dissolve 196 grams of ammonium ferrous sulfate in 800 ml of water. Now add 20 ml of concentrated sulfuric acid to it. When all the chemicals are dissolved properly, make up the volume to 1000 ml. Next comes the potassium dichromate. This has a molarity of 0.167 molars and it is prepared by dissolving 49 grams of potassium dichromate in 1000 ml of water. As an indicator, we are using the ferroin indicator, which is prepared by dissolving iron sulfate heptahydrate and phenanthrene indicators in 100 ml of water. We also need concentrated sulfuric acid, which should be approximately 96% pure. The hazardous chemicals involved in this process are sulfuric acid and potassium dichromate. Both of these chemicals are hazardous to health in the way of respiration and corrosion. The preparatory time to prepare all of these chemicals is approximately 45 minutes and requires expert handling at every stage. In order to perform the Walkley Black method, we need 2 conical flasks for one single soil sample. One will be named blank and the other will be named soil. So we start off by taking 1 grams of soil and putting it in the conical flask. Next up, we add 10 ml of potassium dichromate solution in both of the conical flasks. After the addition of potassium dichromate solution, we add 20 ml of concentrated sulfuric acid. You need to be very cautious at this stage. Now, both of the conical flasks are kept for rest for at least 30 minutes. Now, as 30 minutes are over, we now add 200 ml of distilled water in the blank conical flask. We add 200 ml of distilled water in the soil conical flask as well. Now we add 4 drops of the ferroin indicator. And now we titrate the blank conical flask first against the Mohr salt. We note the initial and final readings. The end point for this titration is brick red color. And now we note the end point on the burette. We now titrate the soil sample. As the endpoint is achieved, our titration is now complete. Now we have the readings of the titration and we will put it in the formula to achieve the organic carbon percentage. We put the values in the respective places. So this is the final organic carbon percentage.